Welcome, good people. Today we'll be doing Gauteng paper 1, September 2025. So without wasting time, question 1 says given f of x equals to x squared minus 3, 3x minus 1 and x plus 2. Solve for f of x equals to 0. If x is an integer, x is a rational number and x is a real number. So we first and foremost have to just write down what we have, and x plus 2. And they say this is equals to 0. Now, we know that x squared minus 3 is equals to 0. 3x minus 1 is equals to 0. And x plus 2 is equals to 0. Whereby we're having x on this side equals to the plus minus 3. And then x here is equals to 1 over 3. And then x here is equals to minus 2. And they say if it's an integer is a whole number from negative infinity to positive infinity. And here our whole number is negative 2. Thus, we can conclude by saying x is equals to negative 2 only. Okay? And now they are saying a rational number. A rational number is a number that should look appropriate to the eye, like a fraction or a whole number or a natural number, and so on and so forth. And in this case, our x will be 1 over 3, or our x will be negative 2. And then a real number is a real number, as long as it doesn't have an I in it. Okay, guys? So it's what? X is equals to plus minus square root of 3, or x is equals to 1 over 3, or again x is equals to negative 2. This is what we have. Now moving on, they are saying solve for x. Solving for x, this looks like a quadratic. Oh yes, it is. And then they are saying correct to 2 decimal places. So that alone shows that we can use the quadratic equation. There is no way you can do it by head unless you are those super geniuses, you know. Yeah. So the quadratic, let me just substitute. So we know that x must be equals to minus b, where our b is 9, plus minus square root, our b is minus 9 squared, minus 4, our a is negative 15, and our c is 4. And then our a is negative 15. Now, getting our roots, we have x being equals to 0.30. Remember, 2 decimal places. Or x is equals to negative, 0.90. 2 decimal places. Remember, good people. Now moving on, we have 3x minus 2 all squared is greater or equals to 3x. So we know that what we should do here, just to expand and take the 3 that side. So expanding, we have 9x squared minus 2 times 2 is 4. 4 times 3 is 12. 12x plus 4 minus 3x. I just took this 3 that side is greater or equals to 0. Okay, simplifying, we have 9x squared minus 15x plus 4, which is greater or equals to 0. Factorizing this, we'll have 3x minus 1 and 3x minus 4, yes, which is also greater or equals to 0. And then should I say our critical values here? Let me just do that. Our critical value will be CV will be x is equals to 1 over 3, or x is equals to 4 over 3. Why am I saying critical value? Guys, remember, this is an inequality sign. So thus we have to draw our parabola. Y is a quadratic, remember. Now using our critical values, we have 1 over 3 and 4 over 3. And the question says where this function is greater than 0. Okay? We know that what they mean is where this graph is drawn above the x-axis, y greater above the x-axis, and we know it's greater in this direction, and also here it's above the x-axis. Thus we can conclude the question by saying where x is less than or equals to 1 over 3, or x is greater or equals to 4 over 3. Remember, it's greater this side, it's greater that side. Okay, good people. Now moving on, we have 5 to the power x equals to 5 into 4 plus 2 to the power 2 minus x. Now again, if you don't know what to do, you do what you know. We know that 5x is equals to 5 times, let me just expand, this is what I know. Expanding, I'll get 5 times 4 is 20, plus 5 times 5 to the power 2 minus x. We know that this is the same as 5 to the power 3 minus x. When bases are the same, we add the exponent. Okay? Now we can rewrite this again as x equals to 20 plus 5 to the power 3 times 5 to the power minus x. This is what we get. Again, taking everything that side, we'll have 5x minus 5 to the power 3 is 125, minus 20 minus 125 over 5 to the power x, which is equals to 0. And then simplifying again, multiplying everything by 5 to the power x, we'll have 2x minus 2 times 5x minus 125, which is equals to 0. So already here, we can use two methods. If you are like me, I would say let 5x equals to k, right? And we know if that's the case, we'll have what? We'll have k squared minus 20k minus 125 being equals to 0. And solving for k, we'll have k. Where's my calculator? We'll have k as minus 25 and k plus 5, which is equals to 0. Therefore k is equals to 25, or k is equals to negative 5. Sorry for the bad handwriting, guys. Alright, this is what we have. We know that this is not possible. Okay, let me not lie for now. Let me not lie. we know that resubstituting everything, we can say 5x is now equals to 25, or 5x is equals to -5. And we know that this is not possible. Thus, we can now focus on this part whereby it's saying 5 to the power 25. And we know 5 to the power 2 is the same as 25. 5 to the power 2. Thus, we have x being equals to 2. And there you have it. 1.3. Yes, it's for 4x. Now, these people, these examiners, but it's fine. Here they were just trying to test your logs, whether you know your logs. If you know your logs, you'll know that log 16 base x equals to 4 is the same as x to the power 4. Remember, x log 16 base x is the same as x to the power 4 equals to 16. If you know your logs, and you know that x is therefore equals to square root of 2. Remember the plus and minus sign. Okay? Remember that this is what we have. So already we have our x value. Imagine, just like that, we have our x value. Oh, sorry, not square root. I forgot. Where's the trap? I'm so sorry. This is a mistake. Yeah. We get x to the power 4 minus 16 equals to 0. This is the same as x minus x squared minus 4. X squared plus 4 equals to 0. And then we have x minus 2. What am I doing, guys? I'm so sorry. What am I doing? Why am I complicating life? Alright. So we know that for us to get this, we have to do this. Whatever, quadruple it both sides, we'll have plus minus x equals to plus minus 2. That's what we have. So we've already solved for our x, right? Now, after solving for our x, we just have to substitute everything in y. And remember, they say where x is greater than 0, so we can therefore conclude by saying our x must be equals to 2. So thus, we can now substitute our 2 into the other equation, 2 plus 7 equals to 2 plus 1. Y is equals to 9 square root. Sorry, I'm being too fast. You see, when they say speed kills, y plus square root of 9 equals to 3. And you know that y plus 3 equals to 3. Therefore, y is equals to 0. Something's wrong with my pen, but it's okay. And there you have it. You have solved for your values. Now they are saying calculate the numerical values of p so that x squared plus p into 2x plus 7 plus 8 is a perfect square. This looks untidy, so let's tidy up. So we have x squared. Expanding, we'll have 2p hypo. What's wrong with this pen? 2px plus 7p. Hey, what's wrong, guys? 7p. 7p plus 8. This is what we have. And now, they are saying a perfect square. For us to have a perfect square, we know that our delta must be equals to 0. And again, delta is the same as b squared minus 4ac, right? So now we know our b. Our b is 2p, our a is 1, and our c is 7p plus 8. So substituting everything that I've said, whereby b is 2p squared, remember the squared, minus 4, our a is 1, and our c is 7p plus 8, right? So we'll have, this must be equals to 0. Why perfect square? So we have 4p squared minus, simplifying this, we'll have 28p minus 32, which is equals to 0. And we'll have 4, taking 4 out as the common factor, and simplifying, we'll have p plus 1 and p minus 8. This is equals to 0, and therefore we have p as negative 1 or p as 8. Is there another question? And no, there isn't. So this question was simple. Well, just a bit of mind games here and there. So yeah, guys, this is what we have for question 1. I hope you guys enjoyed, and yeah, feel free to ask if there's any uncertainties. Good day, bye. Welcome, good people. Today we'll be doing question 2 of Gauteng paper 1 mathematics, September 2025. So, without wasting time, the question is as follows. The following sequence of numbers form a quadratic number pattern: negative 3, negative 2, negative 3, negative 6, negative 11. 2.1. The first difference of the given sequence also form a sequence. Determine an expression for the nth term of the first difference. The first difference, you know that it's this, it's this, which is 1, this, which is negative 1, this, which is negative 3, this, which is negative 5. And let's just write it down. We'll be having 1, negative 1, negative 3, negative 5. This is what we have. And from our formula sheet, we know that Tn for the arithmetic, there's an arithmetic equation. We will have a plus n minus 1d. And we know that our d here, our a is the first term, which is 1, and then n minus 1. Our d here is negative 2. Simplifying everything, we'll have our, we'll have Tn as negative 2 and plus 3. And there you have it. The following question, they are saying, calculate the first difference between the 35th term and the 36th term. So we know that our Tn from above was negative 2n plus 3. Okay. So now, these people they like tricking you guys. They like tricking you. So simply they just want T36. T36 is equals to negative, so not T36, T35. What am I saying? T35. T35, which is equals to 2, negative 2, well, n is 35, plus 3. Yeah, therefore, we have T35 being negative 67, and there you have it. Okay, moving on. They are saying determine an expression of the nth term of the quadratic equation. So basically just have to show them the nth term for 4 marks. So let's begin. We had -3, -2, -3, -2, -3, I believe. Yeah, -6 and -11. -6 and -11. This was our quadratic number pattern. So again, just show them that you know your story. -2 minus -3 was 1. This was -1. This was -3. And this was -5. Okay? Again, we know we are showing them our story. Our second difference, -1 minus 1 is -2. Again, -2. Again, -2. So first and foremost, we know that the sequence is 2a minus the second difference, right, which is -2. Therefore, our a is -1. Okay. Secondly, our other part will be 3a plus b is equals to the first difference, which is 1, right? And substituting, we'll have a as -1. Yeah, -1 into plus b is equals to 1. Therefore, b is equals to 4. And then last but not least, a plus b plus c is equals to the first term, which is -3. And we know that, we know that our a was -1, our b was 4, equals to -3. Therefore, our c value is equals to -6. So to conclude, our general term will be -n squared plus 4n minus 6. And there you have it. They are saying explain why the sequence will never contain a positive term. Alright guys, this question can think of it generally or look at the function. What I'll do, I want to show them. I like showing them things, you know. We know that our Tn is actually equals to -n squared plus 4n minus 6. Okay. Now, what I would do here, I would want to write this in that turning point method style, you know, whereby I'll have to complete the square. And, you know, for me to do that, I'll have to show them that this is 2 minus 4n plus 6. And for me to get the turning, so for me to complete the square, I know it must be -n squared minus 4n, and this will be 2 divided by 4 divided by 2 times all squared. Yeah, so it will be 4 divided by 2 all squared. But what I do, I must also exclude it. 4 minus 2 all squared plus 6, right? And eventually I'll formulate this function as n minus 2 all squared plus 2. Okay. Yes. Therefore, my Tn is equals to and minus 2 all squared minus 2. Thus, my turning point, my TP, will be 2 and negative 2. Why is this important? This simply shows that our turning point cannot have any negative value, any y value, because it's, should I say, how can I draw this? But TP is negative 2. Yeah, this is why our turning point will be negative 2 at x equals to 2. Already is below the x-axis. So it's like this. If you can't see it, this will be at negative 2, where x is 2. If I can draw it. Yeah. So it will be like this, guys. That's why the turning point is already below the x-axis. So it cannot have any positive value. Okay? And yeah, that's what we had for question 2. I hope you guys enjoyed the video. Yeah, make sure to like, subscribe, share, all those things. Good day. Bye. Welcome, good people. Today we'll be doing question 3 from Maths Paper 1, 2025. How day? September. Alright, the question is as follows. The graphic below shows dartboard from which patterns relevant to the different circles can be derived. The largest, or the radii of the largest circle and then moving to immediate inward circles is given by 18, 6 root 3 and 6. And the innermost circle has a radius of 2 over 3. So just for us to be able to understand what they're talking about, they're talking about these circles, guys. Yeah, these circles until this circle. Okay, that's what they want. Now the question says, show that the area of the circles form a converging geometric sequence. For us to have a converging geometric sequence, our R value must be between negative 1 and 1. Okay, so area 1, we know that the area of a circle is given by pi r squared. Okay, and we know for the first area, pi, our r is 18, and then squared, will yield, pressing my calculator, this will yield, bear with me now, 324. Yeah, 324 pi. The second one, area 2, saying it's 6 root 3 all squared, will give us 108 pi. And the last one, 6 squared, will give us 36 pi. Now our R, it will be area 2 over area 1, which is 108 pi, over 324 pi, which will give us 1 over 3. Thus, therefore, R is equals to 1 over 3, which is converging. Alright, moving on. Calculate the number of circles in the sequence forming the dart board. Now, for me, already we have worked with areas. So let's continue with areas. So the first area was 3 to 4 pi. The second was 3, sorry, not 3, man. it was 108 pi, and the last one was 36 pi. And then they gave us a condition where they said the innermost circle, in other words the last circle, has a radius of 2/3, right? Thus the area of that last one is given by pi 2/3 squared, which is the same as 4/9 pi. So the last one will be 4/9 pi. Okay guys, and we know that for a geometric sequence, Tn is given by this a r n minus 1. This is the formula. And initially what they want how many terms or how many circles are there in this dot, okay, which is n. Now our Tn was 4/9 pi equals to, our first term was 3 to 4 pi. Our r was 1/3 n minus 1. So far so good. So dividing 3 to 4 both sides will yield pressing that calculator would yield 1/7 what? Yeah, you know this thing of using your head. Alright, so it's 4/9 divided by 3 to 4, which is 7 to 9. Yes, equals to 1/3 n minus 1. And we know that 3 to the power 6 is the same as 7 to 9. Thus 1/3 to the power 6 is equals to 1/3 n minus 1. Okay, when bases are the same, we can equate the exponent. Therefore 6 equals to n minus 1. Thus n is equals to 7. So there are 7 circles in the dot. Alright, moving on. They say write the series in sigma notation. It's not necessary to calculate the value of the series. That's beautiful. So we know that you can see there's a sequence here, 1, 5, 9, 13. So it will be 1. What am I signing? So it will be 1. 1, 5, 9, 13 until 81. Okay, and this is an arithmetic equation. So the first Tn is actually equals to, for an arithmetic, the first term plus n minus 1 d. Okay, and we know that Tn, our first term is 1 and our difference is 5 minus 1, 4. Yeah, n minus 1, 5 minus 1 is 4. Therefore Tn 1, let's call it Tn1, is actually equals to 4n minus 3, right? But now remember, for us to have a summation, our summation is n minus. We want to know how many terms are there. So for us to get how many terms, we're just going to use the last term, which is 81. So 81 equals to 4n minus 3. Therefore, n equals to 21. Okay? And there you have it. Now, we are not done. The second part is 2, 6, 10, 14, until 82. Plus. Yeah. So finding the general term for this, it will be again an arithmetic sequence, a plus n minus 1d, whereby we have a as 2, n minus 1d, which in our d here again, it's 4. Okay, guys? Alright. And then we will have tn being equals to 4n minus 2. Alright, this is what we got. So there's 21 terms, right? And remember, they multiplied the first term and the second term. And to write it in sigma, we do the same. We multiply both of the formulas or general terms, which is 4n minus 3, and then 4n minus 2. And there you have it. You are done with 3.2 and moving on. Oh, I once did this, but it's fine. Let's redo it together again. So the question reads, in a series, a plus ar plus ar squared is the sum to infinity is 1, right? And in the series where the terms are the squares of the above series, the sum to infinity is 1 over 5, or 5 over 6, sorry, 5 over 6. Determine the common ratio. Okay? Now, let's just rewrite the above mentioned. This thing is fighting with me. Alright. So the above series is AR. Let's call it T1. T1 is A plus AR plus AR squared. Must be equals to 1. And then T2, they said is the square of the above, which is A squared plus A squared R squared plus A squared R cubed. Quadrupled, or how you call it, must be equals to 5 over 6. Okay. Now we know that the formula for sum to infinity is equals to A over 1 minus R, where R must be between 1 and negative 1. Okay? So for the first term, they are saying our first term must be equals to 1, sum to infinity, A over 1 minus R. This is what we have, okay? And thus our A value is actually equals to 1 minus R. I hope you guys are together with me here. Now, moving on to term number 2. Remember they squared term number 2, okay? So again, sum to infinity is equals to 5 over 6, okay? While you do those A's and whatnot, you will get A squared over 1 minus r squared. Okay, substituting this a in here, we'll have 5 over 6 is equals to 1 minus r squared over 1 minus r squared. Cross multiplying, we will have 5 into 1 minus r squared equals to 6 1 minus r squared. Okay, simplifying, we will have 11 r squared minus 12 r plus 1 equals to 0. And then factorizing, we have r minus 1 also into r minus 1 equals to 0. Therefore, we have our r value as 1 over 11, or r equals to 1. And we know that this is not applicable. Okay? The ratio must converge. Okay, remember the condition. The ratio must converge. And there you have it, good people. I hope you guys enjoyed this video. Make sure to share, comment, like, all those things, and have a beautiful day.